So in this segment, we want to talk about quadratic equations. What is the meaning of a quadratic equation, and what are the different parameters associated with a quadratic equation? So if you look at it, this word is composed of two parts. One is the equation, which means that it should have a equality sign, and it's quadratic, meaning we need to have a quadratic polynomial. So when we say that we have a quadratic polynomial, it basically means that the degree of the polynomial is going to be 2, right? So basically a quadratic equation is an equation with degree 2, and let's investigate the different parts of this quadratic equation. First of all, there's going to be a variable. So again, you can have quadratic equation in many variables. So for example, if I take the equation x square plus y square is equal to 9, right? So in this particular equation, you will notice that there are two variables. So this is an equation in two variables, and the highest power of the variable is 2, meaning that this is a quadratic equation in two variables, right? Whereas if I take a look at this equation now, x square plus y square plus z square is equal to 11. The highest power of the variable is 2, but you will notice that there are three variables here. So there are three variables, and therefore this is a quadratic equation in three variables, right? Whereas take a look at this equation, say x plus 2y is equal to 9. So over here you will again notice that there are two variables which are x and y. However, the power of x and y is 1, which means that this is actually a linear equation and not a quadratic equation, right? Then if you take, say, x square is equal to 5. So in this case, you will notice that there is an equation. There is only one variable, which is x. So this is one variable. And the highest power of x is 2. Therefore, this is a quadratic equation, right? So this year, we are going to talk about quadratic equations in just one variable, which means that you should be seeing only a one variable in the given equation. And that variable could be x, y, z, a, b, m, l, n, and so on. And it has to be quadratic, meaning the degree of that particular equation has to be 2. So let us look at a few equations and let us decide whether they are quadratic or not. So let's consider the following equations. Let us look at the first one. We have 3x square plus 5x equal to 8. There is just one variable here, which is x, right? And the variable has the highest power of the variable happens to be 2. Therefore, yes, this is a quadratic equation. So this is a quadratic equation in the variable x, right? Let's take a look at the second equation now. I have x square minus 5x. So let's write this properly again. X square minus 5x plus 11 equals x square. Now, if you take a look at it very closely, initially it appears that it's a quadratic equation. But you will notice that I can cancel x square from both sides. Or in other words, when one x square moves to the other side for subtraction, x square and x square will cancel. So let me show that. So this would be x square minus x square, right? Minus 5x plus 11 is equal to 0. Now x square minus x square cancels, which means minus 5x plus 11 equals 0. this is not a quadratic equation because the degree of this particular polynomial is just 1, right? And because the degree is 1, we know that if the degree is 1, it can be called as a linear equation. So this is a linear equation. This is a linear equation in the variable x, right? So it's not a quadratic equation. Take a look at the third equation. Again, from both sides, you will notice that x cube and x cube cancels. So I can simply cancel x cube and x cube from both sides. So I again get 5x equals 10, which means that this is now a linear equation. It is a linear equation in the variable x, right? It's not a quadratic equation anymore. Take a look at the fourth equation. You will notice that I have 5x on both sides. So that 5x can cancel and therefore I get x square equal to 0. Now x square equal to 0 is a quadratic equation because the highest power of x in this equation happens to be 2. So I would say that yes, this is a quadratic equation. And it is a quadratic equation in a single variable, which is variable x, right? So x square equal to 0 is a quadratic equation. Moving on to the fifth one, now here I have 2x square and I have a single x square. So what I can do is I can shift this x square to the left hand side for subtraction. So I get 2x square minus x square plus 10x plus 8 is equal to 0. Now 2x square minus x square is equal to x square. So x square plus 10x plus 8 equal to 0. This implies that this is a quadratic equation because the highest power of the variable is x and it is a quadratic equation in a single variable, right? So this can be labeled as a quadratic equation in variable x, right? Now taking a look at x square equal to 0, x square equal to 0 basically again is a quadratic equation. So is a quadratic equation again in variable x, right? In the variable x. And this is because the highest power of x is 2 and there is a equality sign and there's a single variable. So this is a quadratic equation in one variable. And take a look at the last equation. Again, this is a single variable equation. You have a x square term, you have a x term and a constant term. So yes, this is a quadratic equation. This is also a quadratic equation in the variable x, right? So this is how you identify whether you have quadratic equations or not. And I'm going to take a few more questions. The idea is you try to open up all the brackets that you have and you try to bring all terms on one side. If the degree of that polynomial is 2, then it definitely means that it is a quadratic equation. If the degree is not 2, that is if there is no x squared term or no variable squared term, it is not necessary that all quadratic equations would be in variable x. They could be in some other variables also, but the degree of that particular variable has to be 2. So there should never be a power of the variable which is greater than 2. The highest power of the variable has to be 2 for a quadratic equation. So let's take some more problems and identify whether they are quadratic equations or not. So let's take a look at these 4 equations and identify whether they are quadratic or not. Let's open up the bracket here. So if I open up the bracket, x into x will become x square, right? So I have x square. And x into 3 will become 3x, so plus 3x. Then 5 into x will become 5x. And 5 into 3 will become 15. So I have opened up the brackets term by term. And now you will notice that 3x cancels from both sides. So essentially what we get is we get x square plus 5x plus 15 is equal to 0, right? This is my equation which cannot be simplified further. Now let's check. The highest power of x is 2. So yes, this is a quadratic equation, right? In the variable, so there is a single variable here, which is variable x, right? So x square plus 5x plus 15 definitely qualifies as a quadratic equation. Let's try the second one now. So x plus 8 the whole square equals x plus 6 the whole square. I can open up these brackets by a plus b the whole square. A plus b the whole square would be a square plus 2 times a times b plus b square is equal to a square plus 2 times b times a plus b square. So now let us see what we get. This is x square plus 2 8s are 16x and 8 square is 64 is equal to x square plus 12x plus 36, right? Now you will notice that there is a 1x square and 1x square term on both sides, so it cancels, and now we are left with a equation, of course in variable x, so it is a equation in single variable. However, the power of x here is just 1, which means that this is not a quadratic equation, it is a linear equation, and that too linear equation in a single variable, which is x, right? So the second one is not a quadratic equation because the term x square vanished. Now let's take a look at the third one. We have x into x square plus x plus 1 is equal to 0. Let me open the brackets term by term. So x into x square becomes x cube and x into x becomes x square and x into 1 becomes x. So plus x is equal to 0. This is an equation definitely, but the highest power of x over here is 3. That means this is not a quadratic equation. It is not quadratic. However, this is called a cubic equation because the degree of the variable is 3, right? Therefore, this is called a cubic equation. Now, let us take a look at this equation, the fourth one. Let's open up the bracket. So x into x square becomes x cube and x into x becomes x square and x into 1 becomes x is equal to x cube minus 11. So again from both sides you will notice that x cube minus x cube will cancel. So this becomes x square plus x plus 11 is equal to 0, shifting the negative element to the left hand side. And the degree of this equation is definitely 2. That means yes, this is a quadratic equation in one variable, and that variable happens to be x, right? So this is how we can identify whether a given equation is quadratic or not. Let us take some more examples. So let's take a look at these 4 equations now. We have to identify whether they are quadratic equations or not. So again, let us open up the brackets in the first problem. X into 1 by x is 1, right? So x and x cancels, and x into 3 is 3x. So this is plus 3x equals x square. And now I can arrange all the terms on one side. So let me shift the x square to the left hand side. So it becomes minus x square plus 3x plus 1 is equal to 0. The highest power of x here is 2. So this is definitely a quadratic equation. And that too, it is a quadratic equation in a single variable, which happens to be the variable x, right? So this is a quadratic equation because the highest degree of x is 2. Now let's take a look at the second equation. So x square into 1 by x becomes x. So let's open this term by term. X square into 1 by x plus x square into 1 by x square is equal to x square, right? And x square into 1 by x is x plus x square into 1 by x square is 1 is equal to x square. Arranging all the terms on one side again, I get minus x square plus x plus 1 is equal to 0. So you will notice that yes, this is a quadratic equation. This is a quadratic equation and in the variable x, right? Because the highest power of x here is 2. Let's take a look at the third and the fourth one. So here I will have to take the LCM if you notice. So let's find the LCM of 1 and x. The LCM of 1 and x is x, right? Therefore we get the LCM is x and 1 is multiplied by x. So numerator is also multiplied by x, which becomes x square right? So it becomes x square. Let's note it down properly. It becomes x square plus 1 is equal to 3. Now the x goes to the other side for multiplication. So I get x square plus 1 is equal to 3x, which implies x square minus 3x plus 1 equal to 0. So yes, this is a quadratic equation because the highest power of x is 2, and this is a quadratic equation in variable x. So what I'm trying to tell you here is, specifically in the third question, you might think that this is actually a linear equation, right? And therefore, it seems like it is a linear equation because the highest power of x is 1. But you should always simplify that particular equation, and you should find the LCM, and then you should make sure that you group all terms on one side so that you can decide whether it is a quadratic equation or a linear equation or something else. So whenever you have brackets or whenever you have terms to combine using LCM and so on, always do that combination before you decide whether it's a quadratic equation or not. So let us similarly solve the fourth one. Again, I can take the LCM of 1 and x. The LCM of 1 and x is x, right? So the LCM is definitely x. This 1 can be multiplied by x, so this numerator becomes x square minus 1 is equal to 7. X goes for multiplication, so x square minus 1 equals 7x, which implies x square minus 7x minus 1 is equal to 0. And you will notice that yes, this is a quadratic equation in x because the highest degree of x or the highest power of x is equal to 2. So if the degree of that particular polynomial is 2 and if you see a equality sign, then it is definitely a quadratic equation. Yeah. So let me give you now a few questions to solve, and then we will move on to the next idea. Now, before I give you some questions to solve on quadratic equations, let us understand what is meant by the standard form. Okay, let's understand what is meant by standard form of a quadratic equation. So the standard form of a quadratic equation basically means, if you remember the standard form of a polynomial, basically meant that you write the terms in the decreasing order of the powers of the variable, right? And you group all terms on the same side. So for example, suppose I have an equation which is x plus 3x square equal to 5. So what we will do is, we will group all the terms on the say left hand side. Now that's not necessary. You could group all the terms on the right hand side also. But generally we tend to group all the terms on the left hand side and make the right hand side equal to 0. And I would write it in the decreasing in the order of the decreasing powers of the variable. So I would rewrite this as 3x square plus x and shift the 5 to the left hand side minus 5 equal to 0. So this is definitely a standard form because if you notice the powers of x, the power of x is 2, then the power of x is 1 here, even though it's not written, it means the power of x is 1. And then you have a constant here, right? That means this is essentially 5 into x raised to 0, right? So the powers of x are reducing and all the terms are on the same side. This is the standard form of a quadratic equation. What it essentially means is, in a quadratic equation, you will always have a x squared term, right? Now this is assuming that the variable is x, okay? If you had the variable t, then it would be t squared. So you would have a x squared term, then you would have a x term, you might have a x term, and then you are bound to have a constant. The x square could have some coefficient, so that coefficient is labeled as a. The coefficient of x is labeled as b, right? And the constant is labeled as c. This equals 0. So this is called the standard form of a quadratic equation. So for example, if I take this particular equation, 3x square plus x negative 5 equal to 0. Now if you compare this with the standard form, you will notice that the value of a is 3, right? A is basically the coefficient of x square. So the coefficient of x square is here is 3. That means a is 3. B is the coefficient of x. So b is equal to 1. And c is the constant term. So c is equal to negative 5, right? So you can always write a quadratic equation in its standard form, and then you could find the values of a, b and c. So let me take a few examples related to the standard form. So consider the following equations. Let's write them in the standard form and try to find the values of a, b and c. If you notice here, I should be first taking the LCM. So the LCM is x, and this term has to be multiplied by x. So x into x becomes x square, right? This is x square plus 1 is equal to 7. And this x is in division, will go to the multiplication on the other side. So I get x square plus 1 is equal to 7 times x, which means x square minus 7x plus 1 is equal to 0. This is the standard form of the quadratic equation because I have a x square term, then I have a x term, and then there's a constant. And I have written the terms in the decreasing power of x. So now if you compare this equation with the standard form, you will get a equals 1. Then you will get b equals negative 7. B is negative 7. And the constant c is equal to 1, right? These are the different values of a and b and c that you will get by comparing it with the standard form. So let us now try the second one. In the second one, I have to open up the brackets. 5x into x is 5x square. 5x into minus 3 is minus 15x is equal to 42. Let's rearrange this. So this becomes 5x square minus 15x minus 42 is equal to 0, right? So this is again the standard form. So when you comparing the given equation with the standard form, right, what we get is a is the coefficient of x square, so a is 5. B is the coefficient of x, so b is minus 15, right? B is negative 15. And c is the constant, which is negative 42, right? So these are the different values of a, b and c. Let's try the third one. We have x plus 1 into x minus 1 is equal to 3. So if I open these, I know that this is of the form a plus b, a minus b. So it's going to be a square minus b square, which is equal to 3. Which means x square minus 4 is equal to 0. Now if x square minus 4 is 0, please notice that there is no x term. That means I can write this as x square plus 0x negative 4 equal to 0. Now somebody can say, why not minus 0x? Yes, definitely you can write it as minus 0x also. Therefore, comparing this with the standard form, we get a is equal to 1. A is the coefficient of x square, which is 1. B is the coefficient of x, which is 0. And c is the constant, which is negative 4, right? So this was one example where we saw that b could be 0. So here I'm going to make a note that maybe b can be 0, right? But the value of a should never be 0. That means a should never be equal to 0, because if a is 0, then this is not a quadratic equation anymore. Because if I have 0x square, then it basically means that the term x square is not there and it becomes a linear equation. That's why the value of a should never be 0. Let us try some more problems based on converting a quadratic equation into its standard form. So consider these two equations. Let us express them in the standard form. So we have x into x becomes x square. I will have to open up the brackets. X into 3 is 3x. Then 5 into x is 5x. And 5 into 3 is 15. This becomes 8x plus 15. And therefore this becomes x square plus 8x plus 15 is equal to 8x is equal to 8x plus 15. Now 8x cancels and 15 cancels, which means x square becomes equal to 0. So now here you will notice that there is no x term and there is no constant also, which means if I compare this with the standard form, I will get a equals 1 because the coefficient of x square is 1. The coefficient of x is 0, so b is 0, and the value of c is also 0, right? This is how I get the values of a, b and c. Similarly over here, in the second question, let us now open up these brackets. So x plus 8 the whole square is equal to 15x plus 64. So let's open up the brackets. A plus b the whole square is going to be a square plus 2 times a times b plus b square, right? So plus b square is going to be 15x plus 64. So this becomes x square plus 16x plus 64 is equal to 15x plus 64. Now 64 cancels and 15x comes for subtraction. So x square plus 16x minus 15x is equal to 0, which means x square plus x is equal to 0. So now if you compare this with the standard form, a is the coefficient of x square, which is 1. B is the coefficient of x, which is also 1. And the value of the constant is 0, right? So this is how we identify whether an equation is quadratic or not. And then we also express it in the standard form. So now what I'm going to do is I'm going to give you a few questions and maybe 5 minutes where you should go ahead and you should express a given quadratic equation in its standard form. And then we will deal with the concept of roots of a quadratic equation. So in the following questions, you will have to identify first which are the quadratic equations. That's question 1. The equations are given to you. And in the second one, you have to express the following equations in the standard form. Okay. So I will give you 5 minutes to solve this and then I will give you the answer key also. So this is the answer key. The highlighted terms are the quadratic equations. Okay, and on the right side, I have expressed the equations in the standard form. Okay, so just take a look at the answer and then we will continue. Okay, so now let us move on to the concept of roots of a quadratic equation. Okay, so the roots of a quadratic equation, let's understand what it means. Before we understand the roots of a quadratic equation, if I give you a simple linear equation like x minus 6 equals 0, right? Now, if you have to solve this, what you will do is, you will shift the 6 to the other side and you will say x equal to 6 is my solution, right? You will claim that you have found the solution, which is x equals 6. So what is the meaning of this solution? The solution basically means that value of x which satisfies the given equation, right? So for example, here the equation was x minus 6 equal to 0. There is only one value of x for which this equation would be true, right? So if you take x as 7, then 7 minus 6 is not 0. If you take x as 10, 10 minus 6 is not 0. If you take x as minus 5, minus 5 minus 6 is not equal to 0, right? So this is the only value of x which makes this equation true. Therefore, the root of this particular equation is x equals 6. So solution is also known by the name root, and there is one more name to this, which is the 0, right? So these are the three terms for that mean the same thing. The solution or the root or 0 is that value of the variable which satisfies the given equation. So now this particular logic can be extended even to a quadratic equation, or actually this concept can be extended even to even cubic equations or quartic equations or quintic equations and so on. So if you no matter what the degree of x is, the concept of solution or 0 remains the same. So suppose I have x square minus 6x plus 8 equal to 0. Okay. So now I want to find the solution of this particular equation. Basically, again, just to emphasize, the solution of this quadratic equation means, so it is the value of x, solution of a quadratic equation is the value of x that satisfies the given equation. So let's take some values of x over here. Let x be equal to 3. Okay. So let's substitute x as 3 here. So this is 3 square minus 6 into 3 plus 8 equal to 0, right? So 3 square is 9, 9 plus 8 is 17, 17 minus 18 is minus 1 equal to 0, which is absolutely false, right? So x equals 3 does not satisfy the equation, and therefore x equal to 3 is not a root of the given quadratic equation. So now let's try some other value of x. Let's try x equal to 4. So we have x square minus 6x plus 8 equal to 0. Let us try the value of x as 4. So 4 square minus 6 into 4 plus 8 equal to 0. That's 16 plus 8, 24 minus 24. That's 0 equals 0. So here it definitely means that yes, x equal to 4 is a root, right? Is a root of the given quadratic equation because this particular value of x satisfies the given quadratic equation. So basically, to check whether the given number is a quadratic is the root of a quadratic equation or not, all that we have to do is we have to substitute the value of the variable and check whether it satisfies the equation or whether it makes the equation hold true, right? If that value of the variable is going to satisfy the equation, then we can say yes, the given value of variable is the root of that quadratic equation. So let us take some examples based on this idea. So the first question says, check if x equals 0 and x equals 1 are roots of this given quadratic equation. So that's going to be simple. Let us take the quadratic equation. The quadratic equation is 3x square. So I have 3x square minus 2x minus 1 equal to 0. Let's substitute x as 0. So this would be 3 into 0 square minus 2 into 0 minus 1 equal to 0. So this is 0, 0, and therefore minus 1 equals 0, which is not true, which is false, and therefore x equal to 0 is not the root of the given quadratic equation. Let's now try the same thing with the second value of x. So the second value of x is 1. So let's try whether 1 is the root of the given quadratic equation. So let's again substitute the value of x in the given quadratic equation. So 3 times x is 1. So 3 times 1 square minus 2 times 1 minus 1 equals 0. So 3 times 1 square is 3 minus 2 times 1 is 2 minus 1 equals 0, and this means 0 is equal to 0, which means yes, the value of x equal to 1 does satisfy the quadratic equation, which means that x equal to 1 is a solution or is a root of the given quadratic equation, right? So let's now try the second one. The second question says x equals root 2 and x equals minus 2 root 2. Check whether they are the solutions of the quadratic equation or not. So let us note down the quadratic equation that is given to us. The quadratic equation is x square. So we have x square plus root 2x minus 4 equals 0, and the value of x is root 2. So this becomes root 2 square, root 2 the whole square plus root 2 into root 2 minus 4 equals 0. Root 2 the whole square is 2 and root 2 into root 2 is also 2, minus 4 equals 0. So 4 minus 4 is 0 means 0 equals 0. So I can say yes, this value of x satisfies the given quadratic equation. So x equals root 2 is a root of the given quadratic equation. Now let's take the second value of x. So we have x square plus root 2x minus 4 equal to 0, and the value of x is minus 2 root 2. So this would be minus 2 root 2 the whole square plus root 2 times minus 2 root 2 minus 4 is equal to 0. So let's check this now. Minus square is positive, 2 square is 4, root 2 square is 2, 4 2s are 8. Plus into minus is minus, root 2 into root 2 is 2, 2 2s are 4, and minus 4 equals 0, which implies 0 equals 0. So yes, this is a quadratic, which means that yes, x equals minus 2 root 2 is a root of this particular quadratic equation. And in this second problem, we saw that both the values of x that were given, they were the roots of the given quadratic equation. So let me pause for a few seconds before I move on to the next problems. Okay, let's move on to our next set of questions. So in the first question, check if x equals minus half and 2 by 3 are roots of this quadratic equation. Let us do one thing. Let us now again substitute these values of x in the given equations, and let's see if they satisfy the given equation. So we have 6x square negative x negative 2 is equal to 0. X is negative half, so this is 6 into negative half the whole square. Negative half the whole square minus of negative half, right? Minus 2 equal to 0. So this is 6 into 1 by 4. 6 into 1 by 4 is 3 by 2. Positive half negative 2 equal to 0. 3 by 2 plus 1 by 2 is 4 by 2, which is 2 minus 2 is 0, which means that this equation is true. So I can definitely say that x equals minus half does satisfy the given quadratic equation. So yes, it is a root of the given quadratic equation. Let us now try the second value of x that is given. X is negative 2 by 3, right? So let us now take these values. So x equals negative 2 by x equals positive 2 by 3, right? Let us now substitute this value in the given equation. So 6 into 2 by 3 the whole square minus 2 by 3 minus 2. Let's evaluate this. This is 6 into 4 by 9. After I take 2 by 3 square, it becomes 6 into 4, that's 24. 24 by 9 is 8 by 3. So this is 8 by 3 minus 8 by 3. If you combine minus 2 by 3 minus 2, also it is minus 8 by 3. And 8 by 3 minus 8 by 3 is definitely 0. That means I can say that yes, even x equals 2 by 3 is a root of the given quadratic equation, right? Now let's take the next problem. We have to check if x equals 1 and x equals minus 1 are the roots of this equation. So the given equation is x square minus x plus 1 is equal to 0. Let's substitute x equals 1 and let's see what happens. So we have 1 square minus 1 plus 1 is equal to 0. 1 minus 1 cancels. So 1 equals 0, which is false. It means x equals 1 is not a 0 of the given quadratic equation, or it is not a root of the given quadratic equation. Let us now try this with x equals minus 1. So minus 1 the whole square minus of minus 1 plus 1 is equal to 0. That's 1 plus 1 plus 1. That's 3 equal to 0, which is again false. And that means x equals minus 1 is also not a root of the given quadratic equation. So just to check whether it's a root of the given quadratic equation or not, it's quite simple. You just have to substitute the values of the variable and check whether the equation is being satisfied or not. So let me now give you a few questions to solve based on the roots of the quadratic equation. Okay, these are the questions for you. I will give you around 10 minutes to solve these questions, and then I will conclude today's session. In the next session, we will solve more questions on roots of a quadratic equation, as well as we will start with some strategies of solving quadratic equations. So 10 minutes for you to solve these problems. So these are the answers for the given questions. I hope that you were able to solve these questions. Okay. So let's conclude today's session then.